In this tutorial, I want to prepare a 3D mapping project by importing a textured surface model, creating model views, and importing corresponding mapping templates. I created a project in 1:10 scale and now go to the project tree. So I choose the tab in the bottom left and then see the node 3D modules at the top of the mapping basis. With left click, I select 3D models, right click to load 3D models, and select the file. In the folder Mapping Training Image Rectification, we can find the folder 3D Objects and in there the totem example, which we select. Now a pre-import takes place where the dimensions of the object are displayed. That means I now see a small preview here in the dialog where 1% of the points have been loaded to show me how big is this project in terms of width, height, and depth. So in this context, I can check if the object is in a correct 1:1 scale, or maybe I would rather apply a scaling factor for a non-scale object to import the project scale. This means we always assume in a mapping and metigo map that we get the project at scale 1:1. I say start import now. As a file format, we support VRML or OBJ. For textured surface models, STL format is also an option, where I then have pure triangulation without texture color. So now I see a small plus in a tree in front of the node 3D models, and now I see my deactivated point cloud. I recognize it here in the gray font. I save my project, select the model, right-click mouse button and say Activate 3D Model. And we can now switch to the 3D display. So up here I have the option to switch between 2D display and 3D display and can now see my object. For the display control, there will be an extra tutorial. We now tinker with the coordinate system here because we want to transfer the whole thing into a 2D layout. I got the object with a world coordinate system and now I want to create a new user coordinate system that stands vertically. So I roughly rotate the object the way I want to define it as a coordinate system. And then in the fifth column of the tool section, I select the command create user coordinate system. And then I have options on the right to define the corresponding axis directions according to measured axis or selected points. And we start with the x-axis. I choose the button to measure and now simply measure my x-axis from left to right. And with that, I use the two control points for the vertical axis. That is, I now choose the z-axis and measure the first point here and the second point with left click here. Now when I rotate the object, I can click on show and see my alignment. Now I currently have the coordinate origin here in the armpit where I started with the x-axis. I can adjust that angle quickly and now I can define the origin for my local UCS down here. And now I have to mark 3 times the 0 origin and measure the x value on the left outside here. Then the y value on the front of the chest. And the z value by measuring the sole of the foot here. And then I can say show again and see my frontal view and the coordinate origin here. And I want to save that now and just call it UCS01 and say OK. I save my project so that the UCS is saved to the project. And now I can switch between world coordinate system and user coordinate system in the display. So now I want to use this user coordinate system to generate 2D model views. We go to the left of the project tree on the nodes and model views, right mouse button, create model view unwrapping. That means 4 or 6 views are now automatically generated from the outside or from inside. I choose create model view unwrapping outside 6 views and can now assign a name for the model views here, totem, and now have to choose the created user coordinate system. Say select here. It asks for a scale. The proposed scale is the project scale 1 to 10. I say OK. And the paper area is exceeded. Yes. And we add that to the group all and apply. And I see now in the node model views a small plus. I see the red entry totem. And we have created a container here. If I click on a plus again, I see the grouping of the 6 model views, left, front, right, back, top, and bottom have been created here. And now I switch to the 2D display and see my model views on the paper area. The view from below doesn't make sense on this model, so I go down here to the totem bottom view, right mouse button, remove model view. We go to the top of the menu to layout, paper area, choose the paper size A3, landscape format, OK. And now, as a first step, we have organized the mapping bases so that we can map on the 3D object and then see the mapping on the 2D model views. Now we need mapping classes. The handling of mapping classes and mapping symbols is identical to the classic 2D mapping. That is, we open the class management under the menu Mapping Class Management, import a mapping template. And for this, there is in a folder mapping training, mapping templates, map 5 multilingual, the exercise mapping template totem. We select it. I see the created classes. I add these groups, precondition, treatment, totem, and click on import. Starting with metigo map 5, it is possible to set up multilingual mapping projects for international projects. That means you can create different language layers for each mapping topic and switch between them while working on the project. And now I see that my paper size is still too small. In the menu, go to Layout, Paper Area. In the format, we go to A2. And Layout, Frame, Show Frame. OK. And now I can go back to the 3D view, see my object here, and can now choose any mapping class and make some example entries. On the topic of mapping, there will be an extra tutorial later. And I can switch to a different drawing tool, change the class. I rotate my object and now make some more entries here. And now if we look at the whole thing in the 2D view, we switch the view and then see the corresponding entries on the different model views. The software automatically checks which element is visible in which model view, and so some elements are then displayed several times on the different model views. The quantity survey takes place in the 3D dimensional. So here on the right, I can see the green areas with the corresponding area indication.